Welcome to solverfy.
In this question, we are told to calculate the solubility of manganese hydroxide in grams per liter when buffered at pH 7.0, A, B at 9.5, and C at 11.8. So, just to start with, manganese hydroxide will dissociate to produce manganese 2 plus aqueous plus 2OH minus aqueous. This is solid. So I'm going to do the 9.5 because 7.0 will be easy and 11.8 will be similar to 9.5. So we have a pH at 9.5. Okay. So we are trying to calculate the the solubility in grams per liter. So we need to find the KSP of manganese hydroxide first. So the KSP of manganese 2 hydroxide is 4.6 times 10 raised to the power minus 14. Okay. And at pH 9.5, this is going to be basic. And that means we'll have XX hydroxide. And if we have XX hydroxide, that's going to push the equilibrium to the left, right? So we can also calculate the concentration of the excess hydroxide. Since we know pH is 9.5, then and that is a negative logarithm of H plus concentration, right? We can calculate POH, and if we know POH, we'll be able to calculate the hydroxide ion concentration. So we know pH plus POH is equals to 14. Therefore, the pH that is 9.5 plus POH will be equals to 14. Therefore, POH will be equals to 14 minus 9.5, and that will be equals to 4.5. So POH, which is a negative logarithm of OH concentration, will then be equals to 4.5 is equals to negative logarithm of OH concentration. So concentration of OH will be equals to the antilog of the minus 4.5. And that will give us 3.16 times 10 raised to the power minus 5 molar. So that is the concentration of the hydroxide ion. Now that we know the concentration of the hydroxide ion, we'll be able to calculate the equilibrium concentration. So I'm going to write this equation out again. Manganese hydroxide solid going to manganese 2 plus aqueous plus 2OH minus aqueous. So initially, This is nothing, and this is 0. And we have 3.16 times 10 to the power minus 5 to be equals to the concentration of the manganese of the hydroxide. Then the change is going to be negative. This is going to be nothing, and this will be plus x, and this will be plus 2x because the mole ratio is 1 to 2. Then at equilibrium, we're going to have a dash, and this will be uh, uh, 0 plus hex, and that's going to be hex. That's going to be hex, and this will be 3.16 times 10 to the power minus 5 plus 2 hex, right? So if we write the KSP for this, that will be manganese 2 plus AKS multiplied by OH minus square. So that will be X multiplied by 3.16 times 10 to the power minus 5 plus 2x all square is equals to the KSP of manganese that was said is 4.6 times 10 to the power minus 14. So this is going to be 4.6 times 10 to the power minus 14. Okay. So this will be equals to 4x cubed plus 12.64 multiplied by 10 raised to the power minus 5 x squared plus 9.986 multiplied by 10 raised to the power minus 10 x minus 4.6 times 10 raised to the power minus 14 is equals to 0. So if we solve for x, this is a cubic term equation. So x will be equals to 1.34 times 10 to the power minus 5. And since x is concentration, since it represents molar solubility for the manganese 2 plus aqueous, so x is 1.34 times 10 to the power minus 5 molar. Now, to get the solubility in grams per liter, the molar mass of manganese 2 hydroxide is 88.953 grams per mole, and the concentration is 1.34 times 10 to the power minus 5 mole per liter. So we just multiply the two together. So concentration in grams per liter will then be equals to 88.953 grams per mole multiplied by 1.34 times 10 to the power minus 5 mole per liter. So this cancels this, and we're gonna have 1.2 times 10 to the power minus 3 grams per liter. So you do the same thing for pH 7.0 and 11, and just follow the same procedure, and that's it.